Charity, Mikhail, I'm so glad to welcome you here. Thanks a lot for coming and being with us today.
Thanks
Thank
for
you a
having
lot.
me.
So,
Yeah, thank you, Charity. We're very excited to have you, and let's get started.
yeah, sure, let's go get to the talk.
Awesome. Thanks. It's nice to be here. If it looks like I am doing this from under my bed inside my closet, it's because I am. San Francisco doesn't have much real estate, so I am currently under my bed. But here we are. Also, if I was in front of an audience right now, I'd be like, who here is tired of Zoom? Oh my God, I'm tired of Zoom. Right? It's like so sick of it. But it's better than nothing, right? So here we are. I am going to talk today about the socio-technical path to high-performing teams. And I dearly wish that I could see your faces and reactions because it's really weird, like giving a talk just to my bookshelves. But oh well. I want to talk about teams today. And teams, well, if you don't know who I am, my name is Charity. I'm the co-founder of honeycomb.io, co-author of Database Reliability Engineering. If you have a copy of this book, you might have noticed it came with a horse on the cover. I can fix it. If you let me know, I will send you a sticker of a unicorn that you can put on the cover. Also, Liz Fung-Jones and I are in the middle of writing the O'Reilly book for observability. So that should be out in a couple months. Like I said, we're going to talk about teams today. And teams are really, they're the building block. They're how we organize ourselves in our labor, right? I like to think of teams as like RAID for humans. It's how you get redundancy and failover, and it's how, it's how people can go on vacation without everyone in the company having to know, what's going on. It's how large organizations stay loosely coupled and allow for a lot of autonomy. And teams, the teams that you join will define your career. I talk to people fairly often about their careers, just career counseling them on Twitter. And, when I ask people, what do you want to do next? They often say something about they want to work on such and such technology, or with, Rust or Golang, or a particular database, or they say that they want to work at a big company, or they want to work on, certain types of problems. But I don't think I've ever heard anyone say that they want to work on a really high-performing team. And this is kind of astonishing when you think of it, because, like I said, the teams that you join, they in many ways define the arc of your career more than your personal skill level, more than your own abilities. Well, we'll get to that in a little bit. I was really lucky starting off in Silicon Valley. I spent 5.5 years at Linden Lab working on Second Life. It was a great team. I loved them. They were creative. They were incredibly brilliant. They were idealistic, out to save the world. And then I went to one startup and it sucked, and another startup and it sucked in completely different ways. Like the first one I went to was about gamifying your shopping experience. So trying to manipulate people into spending more money and staying in stores longer. I had a long commute. My manager never talked to me for a year. They praised us every time we stayed up all night. It was terrible. I was really unhappy, and I left after a year and a day. And after I left that startup, I was like, aha, I know what I want now. I want the opposite of these things. I want something where I can walk to work, where it's an easy commute. I want something where I respect the product. I feel better about myself for working on it. I want something where the people are great and I would be friends with them. And so I found a company like that, and it was terrible in very different ways. it was everything that I said that I wanted, but the technology was obsolete. I spent most of my day just translating Word documents and how to set up databases into Puppet recipes. Our weekly meetings were just our manager handing out and saying, all right, Charity, you do this, and Jeff, you do this, and Mark, you do this. And the two bad jobs had nothing in common with each other, except the way they made me feel. And something that I've learned belatedly is, our work is such a huge part of our life, right? It's a third of the hours you spend awake over the course of your lifespan. And some people take the strategy of just like not giving a shit about their work, just like checking in, checking out. I believe that it should be better than that, right? Like, I think that it's part of what makes life meaningful is autonomy and mastery and meaning, right? If you can find a job where you get all three of those things, then it's actually a part of what creatively feeds you. It's a part of what makes your life whole and worth living. And, we're already luckier than 99.99% of all human beings who have ever lived, right? Like, because we don't have to weed turnips every morning. We don't have to, like, I grew up growing our own food, like on a compound in Idaho, and a farm, just like weeding and doing garden stuff. And if my fingernails aren't dirty, I still have a hard time believing that it's real work. But it is. And I think that we should aim higher for ourselves. If you want to read more about this, Daniel Pink has this great book called Drive, which is all about what motivates us. And it was really illuminating for me. So I want to talk about the socio-technical systems that lead into these wonderful environments that are affirmative and creative and make life worth living. And this word socio-technical systems, right? I love it in part, because you know what it means when you look at it for the first time, right? It's social plus technical. It is the people and the technology and the tools that we use to interact between the two. And one of the beautiful things about socio-technical systems is that they're circular, right? That they feed upon themselves. And if you change the tools that people use, you can change their behaviors, and you can even change who they are. If you want to read more about this, I recommend, Dr. Richard Cook's research. He has a bunch of white papers about this stuff. I mostly want to just point out that your system is a snowflake. It is one of a kind. This is why there are no easy answers. This is why you can't just take a run book that some other company has made. Like, here's how you build the system. No, it's going to be different every time. It's going to be incredibly different every time, magnificently different every time. And so all we can do, there's no playbook, there's no solution. There are just feedback loops for us to tune and cultivate. So what can you do? Well, here's a quick list of things that I think that, in my experience, you can focus on. You need to hire growth-oriented people. You need to hire people who are not terrified by the idea of things changing all the time. All right, you need to hire people who are excited by the idea of things changing and being able to grow all the time. You need to build an environment of emotional safety. You need to build an environment where people are not afraid to fail, where they understand that failure happens and it's something that we learn from. It's the only thing that we learn from, right? You need to invest in good tooling. So many companies have foundered on the shores of just like doing everything themselves, right? You cannot be an expert at everything. Your team cannot do everything at an expert level. Having the focus to do the things that are your core differentiators and outsource everything else, that is a strength, not a weakness. Technical debt is not something to be eliminated. It's impossible to eliminate it. It's something to be invested in, and it's something to keep an eye on and pay it down when it starts to, starve your ability to make forward movement. Practicing observability driven development is key because it's like the difference between, blindfolding yourself and versus like seeing clearly. Instrument, observe, iterate, and repeat. This is all about these feedback loops, right? You change a variable once, it's going to have some predictable consequences and some unpredictable consequences. It's going to have, you change it again in a way that you think that you understand. Sometimes it will, sometimes it won't. These are incredibly complex systems, and that means that the only way that you can actually understand them is through experimentation or testing in production. Okay, so let's start here with, we want to build these high-performing socio-technical teams. Well, you can't fix what you don't measure, right? And so it's important to start with, how well does your team perform? This is where I would be asking, who here has read Accelerate, the book by Jez, Nicole, and Jean? And who has read the State of the DevOps, right? The DORA report. We were stumbling around in the dark for years and years, and God bless Jez and Nicole, because now we have some actual science. Turns out there are 4 metrics every single one of your teams should know. You should be tracking these. You should be measuring them every day. Your managers and your leaders should have them up on the walls in a dashboard that they refer to know how well you're doing. Those 4 metrics are: how often do you deploy? How long does it take? How long is elapsed between when you write the code and when it's live in production? How many of your deploys fail? How long does it take to recover from an outage? And the 5th one, which I threw in there, which isn't an Accelerate, but I think it's very important to track, is how often are your people being alerted after hours? Because that's a really good canary metric for how burned out your people are going to be. Every team lead should be watching these. You should know where you stand. If you don't track it, you can't fix it. Besides Accelerate, you should all be familiar with the Stripe Developer Report. They surveyed tens of thousands of developers and asked them where their time was going. And turns out we spend 42% of our time, almost half of our time, on bullshit. Stuff that doesn't move the business forward, stuff where we aren't learning, we aren't fixing anything, we aren't changing things. We're just doing the shit that we have to do in order to get to the stuff that we want to do. That's an optimistic take, right? Like, it's actually probably worse than that. This is self-reported. We're saying that we waste about half of our time. That's kind of unacceptable. It is kind of incredible that we just sit here and are okay with this. How? Why? I feel like the biggest obstacle that we face trying to change things in this industry is the fact that people have just accepted this, and they just assume that it just has to suck working with computers. It just has to be frustrating. It just has to be tedious. It just has to be terrible. It doesn't. It fucking doesn't. And we need to raise our own expectations for ourselves and our teams, or we're just going to be stuck in the pits forever. So back to the DORA reports. It turns out, they've been surveying teams year after year after year now. Turns out there's an enormous gap between the elite teams and the bottom 50%. I don't know if you can see this with my screen. Yes, you can. Okay, cool. But Deployment frequency for the bottom 50% of teams is like between once per week and once per month. Between on elite teams, it's like multiple times per day. That's insane. If you look at it year over year, what we see is that between 2018 and 2019, the elite developers, the elite teams, are getting better, and there are more of them. But at the same time, the bottom 50% are losing ground. How is this? And a lot of people start by saying, well, those are the great teams. Those are the good engineers. Those are the good engineers who are the elite performers. That's actually not true. So many of the best engineers in the world are in that bottom 50%. And so many mediocre engineers are in that, yellow elite performers bubble. The moral of the story is that it really pays off to be on a high performing team. 208 times more frequent code deployments, 2,600 times faster to recover from outages. That's insane. You don't see numbers like that anywhere. Ask yourself, 2 brand new developers, which of them is going to be a better engineer in 2 years? The one on the high performing team who's doing 3,000 deploys per year, spent 6 hours firefighting, or the one who did 5 deploys per year, 65 outages, and was firefighting constantly? Like the differential there, like the difference in the amount of things that the first person will learn, lessons that they've learned, their ability to like solve problems and move on to the next one, like they're going to be they're going to be much better. It's a much better use of your time, it turns out, when you're spending it on creative problem solving than on firefighting constantly. And here's my point. What happens when an engineer from the elite yellow bubble joins a team in the mediocre, like bottom 50%? What happens when an engineer goes from Google to, some mediocre startup? Our instinct tells us that engineer is so special and so great, but actually your productivity tends to rise or fall to match the team that you join within 3 to 6 months. Because most of what defines the speed at which you can ship software and how safely you can ship that software isn't your own knowledge of data structures and algorithms. It is all of the infrastructure around you, the libraries, the tooling, the automation, the deploy scripts, the, all of that stuff that's constructed that provides the platform upon which you write your code. Your code is just the frosting on the cupcake. A lot of people will say the way to build great teams is by hiring the best people from Ivy League schools, from Google, from Facebook. It's fucking bullshit. It's the opposite. It's the exact opposite. Build great teams and they will make great engineers. I have seen this in my career over and over and over. Great teams make great engineers, not the opposite. So every engineering organization has actually a dual mandate. It's not just about building great teams. It's about building great customers too, right? And it turns out these two are self-reinforcing. When you have happier customers, you tend to have happier teams. When you have happier teams, you tend to have happier customers. And the work of like constructing and cultivating these socio-technical feedback loops and empowering engineers to really own the full lifecycle of their code, it really begins with observability. For the same reason that if you're as blind as I am, you put on your glasses before you go driving down the freeway. It's just, if you can't see clearly what you're doing at a really granular level, you're going to waste a lot of time and energy. So let's talk about these tools, right? And granted, I don't know each of you. I don't know your teams, your companies, your biggest problems, but I've seen enough out there. I bet I can guess what most of you need. This brings us to observability. So let's start with the definition. It's a term that we've borrowed from control theory, mechanical engineering, and it means how well can you understand and infer the internal states of the system just by observing its external outputs. In other words, can you look at the system from the outside, understand what's happening on the inside, even if it's a new system state that you've never seen before, even if you've never seen these situations before, even if you've never seen this state before, can you understand it just by asking some questions from the outside? And if you apply this to software, it means, can you understand your systems by asking questions from the outside? Can you debug your code and any of its behaviors using its output, and critically, without shipping new code? Any asshole can understand new system states if you ship new code to handle that state, right? But that implies that you could have known in advance to ship code to handle that state, right? So that's some circular reasoning there. You need to be able to understand new situations without shipping new code to handle it. Now, there are a lot of technical qualifications and prerequisites that go into this. I'm not going to really go into that a lot here because I have written a lot on this topic. You can find it if you want to. Briefly, some things that are associated with observability are the source of truth has to be arbitrarily wide structured data blobs, not metrics, not logs, not traces. You have to be able to visualize by time, though, aka a trace. And what this does so powerfully is that it gathers up the full context of your request and it ships it along with the request as it bounces from service to service. That's why this became so much more critical when we started adopting microservices, right? Before microservices, you could just attach a debugger and step through the code. Well, you can't do that anymore now because your process hops the network. So observability is a way of sort of packing up that context, propagating all of the unique request IDs, unique span IDs, UUIDs, shopping cart IDs, whatever it is. You pack it up with the request, you ship it along with it, etc. Tools out there that are not observability, even if they claim to be while they're trying to sell you it, anything that's based on the metric will not be observability. That goes for Prometheus, Datadog, SignalFX, Wavefront, New Relic. They are not observability, not by my definition. They can't do any of the things that I talk about as being side effects of observability. Unstructured. So the thing is that anything that requires indexes or schemas is getting back to the idea that you had to predict in advance what data you were going to see in order to answer the question, which is not observability, right? If you have these arbitrarily wide structured data blobs, you can derive logs, metrics, and traces from that data type. You cannot go in the other direction. You cannot start with metrics, logs, and traces and derive arbitrarily wide structured data blobs because you discarded that connective tissue at the moment that you wrote it out. There's a lot more. It requires high cardinality. It requires high dimensionality in order to be able to ask any question. I'm not going to go into that anymore here. But if you want to read more, there's a link at the bottom of my slide. A lot of times people come to us and they're like, they've invested 5 years into their monitoring software and their logging systems. And they're like, I super want to invest in observability, but just I can't right now. Later, I totally will after I dig myself out from this hole. And, I don't know your systems, but generally that logic is false because you're probably not going to figure out what's wrong with your systems without some observability. And this is what we hear from people time and time again, is that the best use of your time is to invest in observability first and then debug your other problems. Because it's like wearing a headlamp, right? You wear a headlamp, it's pitch dark, you're walking down the mountain, and you use instrumentation so that you can see what you're looking at before you go and fall off of the cliff. Liz Fung Jones and I wrote up an observability maturity model here. The link is at the bottom of the slide. if you're interested in this stuff, you should go and read it, because we tried to make it like a choose your own adventure. So that you can, read the scenarios for the, 5 resiliency to failure, high quality. The idea is to find the thing that you're worst at and then work to make it better. And then find the next thing that you're worst at and work to make it better. So we've got scenarios here where you can read the scenarios, see which ones resonate with you. And if you're like, oh shit, I recognize this sounds like me, I must be really bad at predictable releases, then we have some suggestions for like how to just start digging yourself out of this pit, right? I'm not going to go into all that here, but it's there. Observability is the key for making the leap from the known unknowns to the unknown unknowns. And that is key to software lifecycle ownership, being able to own your own code in production. This graph on the left here is a diagram of the LAMP stack, the last standard architecture. And the diagram on the right is the United States' electricity grid. The point is, if you look at the LAMP stack, you can predict where the problems are going to be. You can understand it at a glance. You can write a bunch of monitoring checks, set some thresholds, set some pager alerts, and you're pretty much set. But modern systems are a lot more like the one on the right, where problems are emergent. They're unpredictable. You do not know where the next thunderstorm is coming from. You don't know where a tree is going to fall over on Main Street. You don't know where the power grid is going to go down. And so you just have to work on building in observability, building in auto remediation, building in, tooling to help you understand your systems and their failure conditions live. And why now? I mean, it's purely a function of complexity. Our infrastructures now are ephemeral. They're loosely coupled. They're partitioned and sharded and distributed and dynamic and, blipping in and out of existence. It makes perfect sense that the old generation of tools is not designed for this kind of thing, which you can see pretty clearly if you've ever tried to use Datadog or New Relic and found their pricing model is based on like CPU cores or containers, right? It's not the right tool for the job. Observability, through all of these technical things that I mentioned, like high cardinality and high dimensionality, it enables you to inspect cause and effect at the level of the individual request, right? It allows you to tease out correlations and statistical anomalies. It allows you to point at a spike right after you ship your code and say, what's different about those requests than all of the other requests? And map that back to the code that you just wrote, which is pretty necessary if you're asking engineers to truly own the lifecycle of their software. Without observability, you're not helpless, you're not hopeless, but you're reduced to doing a lot of guessing. You're reduced to doing a lot of, inference. When I was a sysadmin, I remember walking in after lunch, scanning the dashboards on the wall, everything's gone to hell, and I'd just look at it and I'd go, it's Redis. Right? And it wouldn't say Redis anywhere on the wall, but I just knew it because I'd seen so many other outages. What's happening with my? See how this works. But I just knew it because I'd seen it before, so I could intuit it, right? That was super fun. I'm not gonna lie. Like I kind of miss being the wizard, but that doesn't scale, man. And if it's a new problem, if it's a problem that you haven't seen before, good luck with that. Oh, I just realized I was kicking my keyboard. There we go. But here's where I want to give you an example, because a lot of times people are just like, okay, kind of makes sense, but give me an example. I can do that. Okay. So let's look at, here's an example of a problem. Photos are loading slowly, not for everyone, but for some people. And this is on the older lamp stack architecture. I'm pretty sure most of you have debugged a problem like this in the past, right? So what are some problems that could happen? Well, maybe we're out of app capacity. Maybe some app instances are down, or we rolled out a bad build. Maybe there's a bunch of errors or latency. So let's look at some dashboards, root causes. Maybe the database has gotten slow. Maybe we deployed a bad query or there's lock contention, right? These are all problems that are pretty easy to anticipate and predict. We should monitor these things. Duh, absolutely. Okay, now let's take the same question. Photos are loading for some people, but in a microservices environment. And all of these scenarios that I'm going to list are taken from real outages that happened at Parse and at Instagram. Okay, I'm not exactly sure what I'm supposed to monitor here. All of these kind of feel like one-offs or weird situations. Some of them aren't even really bugs. I've got more. Latency reverts to historical mean on Tuesdays. I know what you're thinking, but it is not a cron job. I've got more. This one in the push notifications one is one of my favorite outages ever. They were coming to me, they're like, push is down. I was like, push is not down. Like, I'm getting pushes right now. Like, and pushes are in a queue. So the fact that I'm getting pushes means that push is not down. And they kept complaining. And like 2 days later, like, push is still down. I'm like, okay, I'll go look into it. After I don't know how much debugging, we realized that we had added some more capacity to the auto-scaling group where the Android push notifications were being held. And Android, I don't know if this is still true, but Android devices at the time had to keep a socket open. Every device for every app had to keep a socket open to the like delivery server. And so we added some more capacity to the ASG, and we were using round robin DNS to load balance the requests and the sockets. So we increased it to 25 nodes or whatever. And that's when we accidentally, the DNS round robin request result would exceed the UDP packet size, which is fine. It's supposed to be fine, right? Because if DNS, if UDP fails, it fails over to TCP, right? Which it did for everyone in the world, except for some users that were behind a router in Romania. And for them, push seemed completely down. Again, I ask you, how was I supposed to predict this was happening and monitor for it, right? Like, you can't, this is the nature of modern systems and their outages. You cannot fucking predict what's going to happen. You really shouldn't even try, right? You should invest all of that time and energy into instrumentation and into understanding your systems and stop trying to guess how they're going to break, because you can't. You have an observable system where your team can swiftly and reliably track down any new behaviors without any prior experience. This puts you in a kind of constant conversation with your code. It's also known as testing in production, right? So I want to talk about observability-driven development here because it's kind of at the core of the Brave New World, right? And it's how you kind of kickstart this virtuous cycle of you build it, you understand it, you own it. It's all about instrumenting right in front of you as you go along. You never accept a pull request unless you can answer the question, how will I know when this breaks? Because it's not if it breaks, it's when it breaks. Someday it will break. and then you watch your code go out, muscle memory. You do continuous delivery, continuous deployment, so that it, you have a habit of, you hit merge and you go watch for it. And then, you ask yourself, through the lens of the instrumentation that you just wrote, is it working as intended? Is it doing what I expected it to do? And does anything else look weird? That's observability-driven development. TDD was by far the greatest software innovation of my lifetime, right? TDD is great, but it works by abstracting away everything about reality. You're just like, okay, all of the chaos and the uncertainty of the world just doesn't exist. We're just going to mock it out so that we can run these tests, which is fine. It's enough when your production systems are fairly predictable and reliable too. But when your production systems are not predictable and reliable, when you've moved a lot of their normal working out of the VM or out of the code itself and into the operational sphere, it doesn't work very well anymore. Now you have to loop in production as part of your testing if you want to actually have any certainty. When people ask me things like, how can I get my developers to care about production quality? And my first question is always, are they on call? It's time. Developers need to be on call for their code. We need to democratize production. We need to build guardrails so that people can't accidentally break it. But there's a compact here between engineering and management. Engineering agrees to be on call for the code. Management agrees to make sure it doesn't suck. You should not have to rearrange your life to be on call. You shouldn't dread it. It shouldn't interrupt your sleep. I think it's reasonable to ask someone who's developing a 24/7 service to be woken up once or twice a year to support their code. That's all. More than that, you deserve hazard pay. I believe that there's a world in which we can make all on-call rotations completely optional. And I believe that people will want to opt into them because it's where the power is, because it's fascinating, because it's exciting, because it's part of that equation, autonomy, mastery, and growth. Part of that, and meaning, autonomy, mastery, meaning. Part of meaning is seeing it impact your users, understanding the impact on the world, making sure that what you're doing is done well, treating your vocation as a craft. Everyone should be up in production every day. Most people that I talk to have not invested in their deploys nearly enough. We need to fulfill the promise of continuous delivery. Work on progressive deployments. It's not that I'm not saying that staging environments are bad and you should shut them all down. That's not what I'm saying at all. There are some valid use cases for staging systems. The problem is that we all have a limited number of developer cycles, right? It's just law of gravity. We're scarce. We have the scarce number of developer cycles. And unfortunately, most of us are going and spending them all investing in elaborate staging environments, multiple staging environments, a staging environment for every engineer, blah, blah, blah. And then it gets to production and we're like, oh, oops, we're out of developer cycles. And so we never invest that effort into making your ability to see and understand and experiment and tweak and have control over the levers of production. All I'm saying is production comes first. You invest in production first and let staging take the leftovers, not the other way around. Use feature flags, man. Feature flags are a big part of the answer. It's how you decouple deploys and releases. You should not be in a situation where anytime you merge to master, everyone in the world is going to immediately see all your code, right? You should be able to selectively turn it on under controlled environments for certain users at a time, for test users, for internal users, for different groups of users. And service level objectives are ultimately a big part of how we dig ourselves out of this pit of firefighting. And so many people are like, this all sounds great, but I can't do this because I'm a financial institution, I have regulations. Bullshit. just not true. It's a lot of cargo culting. So I want to quickly show you why this is so expensive and why, investing in this stuff is so much, has compounding benefits. We see insidious loops like this every week in our teams where an engineer merges a diff, a while passes because we're not automatically deploying it, right? Many other people merge some diffs. At some point, somebody is like, okay, I'll trigger a deploy. It ships out a bunch of changes at once, fails, takes down the site. Paige is on call, who probably isn't the same person who's running a deploy. So they're manually rolling back and starting to get bisect to figure out which many changes was the problem, which eats up her day and the day of all of the other engineers who happen to ship some changes in there. Everybody's trying to figure out whose change it is. All hands on deck. Everybody bitches about how much on-call sucks. Don't finish until it's late at night. How much time have you wasted? You've wasted several engineering days worth of time. And this probably happens a few times a month. No wonder people start hiring ops teams and SRE teams, take the burden off of them so they can actually write some code. All right, let's look at this loop if we do nothing but implement continuous deployments. Engineer merges diff, which kicks off an automatic continuous integration run, and deploy fails. It notifies the engineer who just merged their changes, reverts it. She knows exactly what she just did, so she quickly fixes it, adds some tests and instrumentation, commits a fix, it auto deploys again. 10 minutes have gone by. Multiply this by week after week, year over year, and you can see what a competitive advantage it is to invest in this stuff. Everyone else is going to be left in the dust. It really pays off to be on a high-performing team. Really. It's part of being human that when we feel unsafe, we start to feel wobbly and we slow down. But it just so turns out that in this situation, that doesn't serve us well. Because when it comes to shipping code, speed is safety. Slow is death. You need to get your code into production immediately while it's still fresh in your head, while you still know what you're intending to do. It's the best preventive medicine. You need to reserve as many of your core engineering cycles for your own key business differentiators as possible. All code is legacy code. Write as little code as possible. Outsource everything that you can. Senior engineers, it's your job to amplify hidden costs and hidden rewards too. You're in the great position to be able to spot and reinforce good habits, but also to surface to decision makers. If we don't take care of this technical debt right now, it's going to cost us months of output down the line. And it's not enough to say that one time. You need to raise it again and again. The people, in charge are making the best decisions that they can given the information that they have, but they don't have the information that you have unless you give it to them. Practice good vendor engineering. Good vendors should act just like they're another team at your company. There's this really, managers need to be on board with this so they stop promoting people only if they write super complicated code that probably shouldn't have been written. The world does not need another time series database, right? But whatever you praise people for and promote people for, you're going to see more of that behavior. So if what you actually want people doing is offloading and outsourcing and doing things that are in the best interest of the company, that's what you need to praise people for, not writing lots of complicated code. To sum up, your system is a snowflake. It's a unique puzzle. It's one of a kind. High-performing teams both contribute to and are a consequence of a well-running socio-technical system because it's all a bunch of feedback loops. So lastly, for extra fun, I just want to look at the socio-technical implications of the dominant architecture models of the last couple of decades. With monoliths, you had the application and the database, right? Mostly predictable failures, mostly known unknowns. You would flip the switch to deploy. changes were very on-off, big bang, right? And this gave us this fear, this real fear of production. If it's off or on, then we need to protect it, prevent failures. And it led to and deploys are scary, right? We were terrified of deploys because most outages and most problems were caused by the chaos that were introduced when we deployed new software. And it led to this very masochistic on-call culture. So, our systems were like these glass castles, very hostile to exploration or experimentation. Well, the good news is newer systems are nothing like that. Newer systems have many services, many apps, many storage systems, and every alert is probably something new and novel. It's dominated by unknown unknowns. There should be very few paging alerts, right? Tied only to SLOs and actual user pain. And because of this, we've been able to embrace failure. We've been able to say failure is your friend. A deploy is a commonplace event. It's not scary at all. We have tools around it to make it safe. A deploy is just the beginning of gaining confidence in your code. Deploys are opportunities, and on-call has to be sustainable and humane. It's more like building a playground, right? We've built a playground out of production. It's robust, it's resilient, it's built for playing. It's built for experimentation, for testing and production. It's human scale. If you send your kid to the playground, you don't want them to fall off the swing and break their neck. It's okay, though, if they get a little bit of a bloody nose in the slide, right? You build some guardrails, not to make everything perfect, because that's fragility, but to make everything eventually okay. Where are we going? Here's the thing. Things are getting so complicated. The next generation of systems won't be built and run by burned out people or people who are exhausted, just checking in, checking out, clocking in, clocking out, following orders. Can't really be done. We can't really model these systems in our head anymore. If you try, you'll be outcompeted by teams with better tools or better focus. Systems are emergent, unpredictable. Runbooks don't work anymore. And we need your full creative self. We need you to show up for work well rested and interested, fascinated, and curious. Your labor is a really scarce and precious resource. And you should only give it to those who are worthy of it. If you have a shitty job, quit it. You only get one career. Don't stick it out and be miserable for years. Seek out high-performing teams that you can learn from. Spend more of your time doing creative things, learning and building, not sacrificing yourself or mired in tech debt. We actually have an opportunity here to make things a lot better. Technology and social changes are all conspiring to give us an opportunity to make life better for the people who come after us than we had. So let's do it. The end.
Wow. Thank you so much. It was really awesome. I'm
Thank
just
you.
I just put probably 3 or 4 pages of notes from your talk. It's really fascinating.
Awesome.
Thank you so much. We're really glad that you with us, and we potentially have a couple of questions. Chat is slightly silenced a bit, but I probably will start with most common question which we heard on DevOps conference, basically we heard in any hallway talk, and basically people asking, and you almost give an answer, but maybe there is some additional color there. People asking, I am in a team, I like a product, I like what we're doing, but team is not really high performant. We have too much of a burden, and people asking like how I can change it. Maybe you have a
How to
suggestion
deal
for
with
people how they can change them.
Yeah. So like that was supposed to be the point of this talk is start with observability, like because you start with observability and you start by, you know, we talk a lot about CI/CD, but most of us only have CI. We don't have CD at all, and that's holding you back. If you can make that an atomic operation where you merge to master and it kicks off, a process where so it automatically within a few minutes is deployed to production, that has all kinds of virtuous ripple effects, like throughout your entire company. It will force you to get good at using feature flags. It will force you to. It will give you the opportunity to like have muscle memory of writing your code and then looking at it. If you can just get your teams to like instrument as they write code, and it automatically gets shipped to production, and then they look at it, you will catch 80% or more of all problems right there before your users ever get a chance to notice. And it's simple, but it's simple, but it's so powerful because you've got this context in your head. You know exactly what you're trying to build, and that context is going to decay very rapidly. You will never again be able to get back to there, right? Like you know more about what you're writing right now than you will ever know again, than anyone will ever be able to know again. And so if you can just like within a few minutes get it live and look at it, oh my God, like that is a game changer right there. And if you are in the habit of looking at your code through the lens of your instrumentation in production every day, you develop a sixth sense for things that are wrong. Right now, most people and their systems are in a state where they're firefighting and they're dealing with really severe problems all the time. The goal is you're never going to not have problems, but the goal is to get out of, oh fuck, like the site is down, oh fuck, this is a terrible thing, oh shit, this is impacting people. Your goal is to get it down to these small things where you don't have big problems all the time, but you're sensitive to the little problems, and so you're seeking them out and you're finding them and you're proactively fixing them before they really get a chance to impact your users. And that's the state that you want to exist in, because that's a state where you can plan in advance for big things, right? They're not going to disrupt your calendar of things that you're planning to build, and it's not going to wake you up in the middle of the night. You can deal with it during the daytime, right? And so all the things that I mentioned, instrumentation, observability, SLOs, and putting developers on call for their own code, those are really critical components for actually finding them. And go read the OMM, the Observability Maturity Model that Liz and I made, which is also in the talk, because it will give you a good starting point. If you read through it, you'll be able to say, which of these 5 things are you worst at? Start there.
Yeah, we have one question, but before we'll come to it, one more, and I probably playing devil advocate here because I heard this discussion like multiple times, and people say, yeah, it's a really cool tool, and you mentioned it, but we are firefighting, and we don't have time to sharpen our tools, and like
what is a really cool tool?
Okay, cool. Now, people saying we're firefighting and we don't have to sharpen anything. We just need to put this fire down. And yeah, they spending it through the year, so they probably never put it down. Any simple tricks which you know for people, at least to move it from like whole house in fires to like at least one room?
Well,
so something which helps them to mitigate it a bit.
I do. The only thing that applies to everyone is stop caring as much. Accept a lower level of service. There are answers for there are things, but like everybody's system is different, and so there's no like one general like magic trick that I can give everyone that will work for you, without knowing more about your systems, except care less. And there are teams that are, for which I joke, but this is the right advice for some people. There are teams who are paging themselves on far too sensitive of problems, or or where they've set their threshold to be like, give me an alert if there's an error. Like, fuck that noise. Like, until you've caught up with, the state of your systems and bought yourself some headroom, maybe your users just need to suffer a little bit for a while. Like I said,
Now I
it's
know
about
the
that dual
answer.
mandate, right? Like, it's that dual mandate. It's the mandate of your organization to have a happy team and happy engineers and happy users. And sometimes in the short term, it's a little bit of a trade-off.
Yeah, now I know. Yeah, it's remind me. I saw one system which had at least one severity incident every day, and they had a backlog of 100 of them. And I seriously want on call to go over it. Like, just remove all of them and say, no, we cannot. It's like very
Exactly.
important. Like, just drop it.
And it's
Yeah.
important. It's important to acknowledge that this comes from a place of wanting to do a good job. This generally comes from a place of engineers who they care about their craft and they take pride in it and they don't want to let their users down, right? And so, like, it's important to honor that. But sometimes it becomes counterproductive if it's actually preventing you from making progress.
That's very interesting line of thought. So you're saying like we care about people, we care about our product. That's why we put a lot of alerting and we put a lot of stuff to like catch everything.
Sometimes you have
And we get
too much alerting. Too much alerting is just as bad as too little, maybe worse.
Okay, well, then we need to talk about SLO. Okay. We have 13 minutes and we have one interesting question, which you probably had a lot already. Person Konstantin would like to have more explanation on storing blobs. If information is not structured, how to figure out info out of it later?
Oh, it's structured. It's very structured. I have an entire blog post on this on my blog about arbitrarily wide structured data blobs. Just look at it. But it has to be structured. That's the point.
Hey, it have to be structured, but doesn't have to have like full schema for it.
No,
So
actually, I think schemas
where is
are.
this age?
Hmm?
Where is the age between like fully structured information, where I just put set of metrics from my code and like stuff which help me to catch unknowns?
Not sure I caught that. But schemas are kind of antithetical to observability because schemas make you declare up front what data you're going to receive. And in fact, you want to incentivize people to just throw in anything that you come across you think might be useful, shove it into the blob, right? Because you don't know what's going to be useful or not. So like, it's hard to without a whiteboard. I wish I had a whiteboard right now, but I've written blog posts about this. Just search for them.
Hey, yeah, folks, just search for Twitter and
Sorry.
Charity have lot of stuff in the.
I'm just like, let's write the JSON blob right here. It's like, no.
Yeah, no, I totally understand you, and I reading your Twitter already for a long time, and yeah, folks, you should go there. It's a lot of interesting information, and Anton is
I rant a
probably
lot.
very yeah, Anton probably bring valid concern. We have software which serves truck drivers, so we are unable to care less about them because it's probably it's health so life critical.
Sorry, you what?
Anton saying it's I'm just reading the chat that they have software which serve truck drivers. So basically, somebody in real world driving somewhere, and software helps them in some way,
Okay.
and it's probably critical for them to have issues in this software.
Okay, so are you saying that every single alert that you get is already actionable and necessary and critical?
So very interesting. Anton, join discussion zone. We will chat about there. But probably I can combine it up. There is class of software where defects and stuff in production is still like critical, and cost of having
Yeah.
issues there it's kind
Yeah.
of high.
I would argue that testing in production is more important than, not less, because there are so many classes of bugs and scenarios and things that you will never, ever, 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 ever encounter in any staging environment, no matter how complex, no matter how closely you mirror production. And it's not that you shouldn't use staging environments, it's that you need to also be testing in production, because only production is production. And if it's that fucking important, then you should be testing in the areas where it actually matters. I mean, come on, all of us have tried to reproduce bugs that, you know, they show up in one environment, they don't show up in another environment, and then you waste your entire week trying to figure out which one is right. Well, when you're testing in production, the answer is easy. The one that shows up in production is right. And if it only shows up in staging, then you don't care, right? Like, the more staging environments you get, the more of these conflicts you're going to have. And, it's up to you to budget your time appropriately.
And probably answering on the question about high severity system, yeah, I agree, and I like this idiom of building playground. And probably a lot of us do not pay too much attention to make sure that whatever you do in production, like you're able to play there. And it's difficult from my perspective, and it's require you to build it in your architecture and like think upfront about it. You cannot just like put a lot of kids into warehouse. They probably will hurt themselves.
No. Yeah, I mean, there are things you can do, like having, test users or a family of test users that follow a schema so that you can periodically prune the data or something like that. But like, I find that the set of technical challenges involved in testing and production are mostly useful, and the set of technical challenges involved in trying to get the data from production to test and staging to be mostly wastes of time.
Yeah, a friend of mine told me one sad story that at some point they finally figure out that they cannot test in staging because of too much of complexity of application and a lot of overlapping stuff.
Yeah.
But
Absolutely.
It took them 10 years.
Exactly. Exactly. I think that what staging is valuable for is testing UI and UX changes. The stuff that you just need to see with your human eye to see, does that look right or not, right? At some point, you can't really machines. And for catching the really easy low-hanging fruit, right? Like, yeah, run it through staging just to see if anything dumb happens, right? But like, anything interesting is going to take concurrency or threads or like lots of connection. Like, so like I come from the database world, right? And the gold standard is capture replay. I have written this piece of software 3 times now to capture 24 hours worth of all database queries, all database, requests to a database, capture everything that happens for 24 hours, and then do post-processing to like reconstruct the transactions and the reads and the writes and everything, and then replay them against an empty cluster, right? So that you can tweak the settings of the config files and like the hardware and just like replay it to do this like very complex benchmarking, right? That is the goal. That is, you should be more paranoid the closer you get to laying bits on disk. That is the gold standard for paranoia. It is not worth doing that level of effort for anything else any higher in the stack. And yeah, like there are times when you're doing like, when you have a very sensitive system and you're doing a version upgrade in your database, do that. But there is, even if you do the gold standard of capture replay, there are still going to be things that happen tomorrow that you never predicted or captured today. The Michael Jackson death, right? Like, famous story of how it took down Google. They had done all this load testing and forecasting and like all this other shit. they did not predict that Michael Jackson was going to die, right? Like there's a certain level of just uncertainty that you just have to accept, and the more comfortable you are with the tooling to like selectively dial back traffic flows, selectively like reduce or do exponential backoffs in your clients, the more controls you have built into production so that you are comfortable, like maybe you went to like unparse, like the platform. We built things that would let us selectively, blacklist individual users or blacklist individual shards or rewrite queries on the fly for individual users, so that for 99.9% of users, it's still up and working normally, and just like the problematic user or app or whatever gets like slightly degraded. Like that's so much better than it taking it 100% down for everyone, right? But if you're not focused on production, you're not going to write those knobs and those very sensitive things that will allow you to do the stuff in real time to keep your system running.
But people still live in these glass castles, from my perspective, and still live in this secure perimeter, monolith, the database, our big famous application. And it's reminded me like a few years ago we had the fireside chat about testing in production, and we just discussing this stuff, and one person asked like, and who give access to developers for production? And we're like, what? Yeah, but probably my question here, any suggestion to people to overcome this fear? And I know the fear is like stopping people from doing the right thing. But
Yeah.
how to give them like some level of confidence that it will not spiral down?
Well, I mean, again, this is very contextual and very individual, right? Like the things that some teams are afraid of are not the things that other teams are afraid of. In general, I think that a lot of the fear comes from, again, software engineers, they want to do the right thing. They want to do well for their users, but they don't know how. So like a thing that we have often done is the first couple of times that they're on call, we pair them up with someone from ops. So they're on call together. So they buddy up, right? And you don't feel bad about pinging your buddy. You just work through the problems together. And after a while, you feel more confident, right? So like training people in that way and giving them the tools, building things into your deploy tools and your monitoring tools and your other tooling so that it's much harder to break production is another way of making it safer, right? Just like doing postmortems of, oops, I typoed this, in the MySQL root shell password. Well, you postmortem that, and then you figure out some things you can do to make it less likely that someone will do that again, right? And you don't blame people, and you're not mean to them, and you thank them for finding these weaknesses in the system. If it wasn't them, it would have been someone else, right? And so you treat them kindly, and you collectively work to make the system more robust and less fragile and less punishing. And a lot of this does come down to how you treat people. And you just like take the approach that failures are inevitable and failures aren't bad. Failures happen all the fucking time, and we can learn from them. It's great.
Yeah, you even don't need to change anything to have fail happen.
What?
Hey, I'm saying you just even do not need to change anything to make fail happen.
Oh yeah, nobody has to do anything. Just like sit there and like feel good about the system. Look away for a second, and something will totally break. Like, of course.
Yeah.
But it's okay. The point is not that things are going to fail. The point is that failures are okay.
Okay, failure is okay. Care less about failures and make yourself and your customers happy.
Yeah, basically.
That's probably it. Yeah, we have last 30 seconds. Any word of wisdom for our audience? Except all the things you already said.
Try honeycomb. It's It's it will help. It's a next generation solution for next generation systems.
Hey, yeah, we need to somehow figure out how overcome this complexity and live with it. Looks like we're already there, and old tooling will not help us. Thank you so much, Shady. We will have a couple of more questions in discussion zone, which will happen soon. And Vlad? And Vlad on mute.
Yeah, mute. Awesome. Thanks a lot for the awesome talk and great Q&A session. It was like a pleasure to listen to. Plenty of awesome information and life experience, probably life changing. So thank you a lot.